To start our sandcasting project, we first found an STL file of a Bulldog online and then used the Driftmeyer 3D printers to print the Bulldog out. Unfortunately, we didn't scale it the first time, so it was huge, but then we reprinted it to a more reasonable size.
Six hours later.
We packed casting sand into the bottom half of a wooden box using a hammer and our fingers to make sure that all of the sand was tightly packed until there was about 1.5 inches left of space. So from there, we set the 3D print and the markers, which would form the molds for runner, vent, and riser. We then packed more casting sand on top of this and set the top half of the box on top of the bottom half and packed more casting sand using the hammer and our fingers to make sure everything was tightly packed until all of the pieces were covered except the top of the marker, which was our sprue.
On our first attempt of creating the mold for their Georgia Bulldog that we're going to cast in aluminum, we definitely placed it in a non-optimal position. The feet were facing upwards, so when we packed in the sand, the small jut out from the paw actually ruptured the top half of the mold. And then doing this ruined the quality of the mold, so then we decided to go for a second time to cast. Our second attempt definitely rearranged the Bulldog in a more optimal position so it would be much easier to pull it out of the sand cast without ruining the quality of the cast. However, something must have happened with the latter part of the sand that we had in our bag, because even though we used the same amount of baby powder, it didn't pull in an even plane. So you can kind of see next to the Bulldog there's divots on either end, and that's not optimal. Although we had to just roll with this because the top of our furnace shattered, so we were losing heat very quickly, and we just needed to pour the aluminum. Otherwise, we weren't going to get a shot at casting whatsoever. So to do this again, I would definitely use a less complex object for this type of manufacturing process. And also, I would be sure to make sure our sand is much more dry. Just because this one definitely gave us a lot of complications. Another thing I would also make sure is to have a different kiln that's more reliable, so that way our rush time doesn't impact the quality of our product.
Oh my god. Whoa, shit!
When it comes to safety for this project, all group members wore safety glasses when the foundry was in operation. The caster also wore fire safety gloves in order to safely operate the crucible tongs that were used to operate the crucible in order to pour the molten metal. To ensure top safety for this caster, Category 2 fire-resistant jeans, Category 2 fire-resistant shirt, a fire-resistant smock, and insulated steel-toed boots were also worn.
Ladies and gentlemen, this is the main event of the evening.
We melted the aluminum using a foundry, a leaf blower, full safety gear, and some crushed cans from Zach's weekend shenanigans. So once the metal was fully melted, we poured the aluminum into the sprue. And lastly, we separated the top half of the box carefully from the bottom half and removed the finished cast mold.
Okay. It looks like a seal. Wow, that's so hot.
They ask you how you are, you just have to say that you're fine when you're not really fine, but you just can't get into it because they would never understand.
Unfortunately, our casting did not meet our expectations. This is because the metal rapidly cooled from the broken foundry and cold ran in the sprue and prevented any additional metal from flowing into the cast. Additionally, we believe there is a gas bubble in the top of the head caused by our vent hole not being large enough.
In conclusion, there are a few key things that we learned during the casting process. First, casting is very challenging if the shape of your part is complex. We failed to make a mold the first time, and we struggled to fix it the second time. Next, we learned that keeping the aluminum at its melting point proved to be more difficult than we expected. We realized the importance of a well-insulated foundry. Finally, we learned about the actual effects of gas bubbles in casting and the importance of quality air vents.